Hey everyone, and welcome to The Explainer. Today we're doing something really cool. We're taking a fascinating chapter right out of an agricultural textbook and transforming it into a high-stakes look at the absolute future of sustainable farming. We're talking about growing real food without a single scoop of soil, figuring out how to save our ecosystems, and actually bringing this cutting-edge agricultural science straight into your own home or classroom.
Okay, let's dive right into this chapter's agenda so you know exactly where we're headed. We've got 1. The soil degradation problem. 2. What is hydroponics? 3. Building your hydroponic system. 4. Essential growth conditions. And 5. Tracking plant progress.
Starting right off with Section 1, the soil degradation problem.
33%. Just let that sink in for a second. According to the textbook data, nearly a third of the total geographical area in India is currently affected by soil degradation. That is a massively alarming chunk of land. And it means we are just rapidly losing the fertile earth that we absolutely rely on to survive.
To really wrap our heads around that number, the source notes that nearly 109 million hectares of land are facing declining soil quality. That is literally mind-boggling. So why exactly is this happening? Well, as the text explains, farming the exact same land year after year strips it of its natural nutrients. Then to compensate for that, there's a heavy use of chemical fertilizers. And unfortunately, that just degrades the soil quality even further over time. Add in erosion from wind and rain, water pollution from industrial drainage, and land degradation from mining, and you've got a perfect storm threatening our food supply.
Which naturally brings us to this million-dollar question. If we're losing our fertile soil at such a rapid pace, how on earth do we continue to grow food? It's a huge pivot point for us. But fortunately, agricultural scientists, nutritionists, and environmental experts have been hard at work on government-backed sustainable solutions. And we're going to explore the most fascinating one today. That brings us to Section 2. What is hydroponics?
I always love a good word origin breakdown. It really kind of demystifies the science, And this one gives us a great aha moment. The term hydroponics is derived directly from the Greek words hydro, meaning water, and ponos, which means labor or toil. So, literally translated, it means water working. In practice, it's a method of growing plants in a nutrient-rich water solution entirely instead of soil. You just completely bypass the need for fertile land. And here's the real game changer. Because you aren't bound by flat fields of dirt, you can completely utilize vertical space. You can build up. This kind of multi-story setup allows you to produce way more food in a fraction of the space, all while constantly recirculating and reusing the water. This is exactly why hydroponics is the driving force behind urban farming, basically allowing us to grow fresh, healthy crops right smack in the middle of concrete jungles.
Let's move on to Section 3, building your hydroponic system.
Now, funneling down from these grand agricultural concepts to some really specific, actionable stuff, the amazing thing about hydroponics is that you can actually build these units yourself. The source outlines 3 distinct DIY systems you can set up to grow microgreens and vegetables. First, there's the wick-based system, which is an awesome starting point. Second is deep water culture, commonly known as DWC. And third is the nutrient film technique, or NFT. Every single one of these methods has its own clever way of delivering that nutrient-rich water right to the plants without a single grain of soil.
Now, getting these up and running requires a structured approach. For a deep water culture system, the physical steps involve setting up a water reservoir and plant cups, and then installing an air blower or aerator. But I really want to highlight step 3 here. The textbook gives a super crucial warning. You're going to be mixing electrical gadgets like submersible pumps near water. You absolutely must maintain strict safety and work under the supervision of a teacher or expert. And honestly, when you're looking up these DIY builds online, always practice good internet safety too.
Section 4. Essential growth conditions.
So putting together the plastic pipes and water reservoirs is really only half the battle. You've built the hardware, sure, but biology dictates the rest. You have to maintain essential growth conditions for these plants to survive. The absolute most crucial element here is oxygen. By aerating the water, you introduce dissolved oxygen, which the plants desperately need. If your roots are white, awesome, you have happy, healthy plants. But if they're brown, that is a massive red flag. They might literally be starving due to a lack of dissolved oxygen. The root color is basically your immediate biological dashboard.
And here's an incredibly practical, almost genius little tip straight from the chapter to help you control that environment. Water plus sunlight inevitably equals green algae. It's just a fact of nature. And that algae is going to compete with your plants and totally hinder their growth. The incredibly simple, brilliant solution? Cover the water surface with a styrofoam sheet to just block the sunlight from entering the water. Simple as that. Controlling the environment like this is absolutely the secret to maximizing your plant growth.
Finally, we've reached Section 5, Tracking Plant Progress.
Because look, a true agricultural experiment isn't just about setting something up and walking away, right? It's about meticulous observation and data collection over time. This framework, pulled directly from the text, shows exactly what parameters you need to track in your own deep water culture system. You aren't just guessing. You are meticulously logging the crop name, the planting date, and taking weekly measurements of both the plant height and the root length all the way through to harvest. This is how you generate real, hard scientific data to see what's actually working.
And you also kind of get to step into the shoes of a chemist, because plants can be incredibly picky eaters when it comes to their water. You'll track the initial water pH, the specific acid you add to modify it, the resulting pH, and then the observable effect on plant growth just 4 days later. You are actively, day by day, fine-tuning the chemistry of your microfarm to make sure you get a high-quality yield.
Ultimately, all of this, the measuring, the testing, the building, it all connects directly back to this powerful overarching narrative from the text. Quote, "Sustainable farming aims to produce food that is healthy for humans with minimum negative impact on the environment." When you track these details in a hydroponic system, you're learning firsthand how to grow maximum food with minimum resources. You're entirely bypassing that massive soil degradation crisis we started with.
Which leaves us with this final, really provocative thought. As fertile land becomes scarcer and scarcer globally, is the future of farming looking up, literally, rather than down? With multi-story vertical hydroponic systems turning tight urban spaces into lush farms, it certainly seems that way. I really hope this explainer has sparked your curiosity and left you eager to start tracking and growing your very own projects at home. Thanks so much for learning with me today.